Right. So yesterday we were discussing average speed and average velocity, and we saw some examples also how to calculate
Yes,
average
sir.
speed, average velocity in different situations. Right. After that, what have we learned till now in this chapter? We have learned distance, displacement, speed, velocity, average speed, average velocity. These are the topics that we have learned.
Sir, regarding the yesterday's class, I have a doubt.
Uh,
Sir,
but
in the previous class, you gave us some sir. Average speed is equals to in that. Once can you go to the yesterday's class notes, sir? Down, sir. Yes, sir. That one.
mm.
Not, not that, sir. Down. Before average velocity, sir. The question.
uh,
Yes, sir. That one. I didn't understand that.
Body travels with speed v1 for one third of time, with speed v2 for one third of time, and speed v3 for last one third of time. What is its average speed? Here, the body is traveling for some time, and that time is divided into three equal parts: one third, one third, one third. This is one third part, this is one third part, this is one third part of total time. In the first interval of time, speed is v1, second part v2, third part v3. So total distance, so average speed is total distance by total time. Total distance is, distances are not given, so we assume them d1, d2, d3. d1 plus d2 plus d3 by total time t. Distance can be written as velocity into time or speed into time. Distance d1 is speed in this interval of time into that interval of time, v1 into t by 3. We do the same thing for second part and third part. Simplifying, you'll get this result.
Why did we get to the denominator as 3, sir, in middle? That I didn't understand.
Where
That purple, yes, sir, that one.
here t will get cancelled, no? In the numerator, if I take out, I can take out t common in the numerator. This t, this t, this t. If taken out, comes common. This t will cancel this t. T is gone. Then what do you have? v1 by 3 plus v2 by 3 plus v3 by 3.
Okay, sir.
So that's what I told yesterday. If you see, this is from this step. If you are not able to understand how you get this step, then look for what is missing in this step. What is missing? T is missing. You should try to understand where the T has gone. Is it cancelled or is it replaced with some other quantity using some formula? You should look that way. Then you can understand it on your own. So we have discussed distance, displacement, speed, velocity, average speed, and average velocity. Okay, right. After this, next is we should understand two types of motion, which are uniform motion, non-uniform motion. Very, very important difference. You should understand this to understand the remaining coming topics. What is the difference between this uniform and non-uniform motion? Okay. Which type of motion is called uniform motion? Uniform, same, similar, which does not change, or which has some common thing, you call it as uniform. You have your school uniform, right? So all the students will be wearing the same color, same pattern of dresses. Uniform. Non-uniform is opposite of this, which is there is if there is nothing in common or if it is completely different, you call it as non-uniform. Okay. Uniform motion is, suppose a body is moving like this. A body is moving like this. It starts at time t equal to 0 second here, and 1 second, 2 second, 3 second, 4 second, 5 second. It is traveling for 5 seconds. Okay. Let us say it covers during the first second of its journey. During the first second of its journey. What is first second? 0 to 1. This is first second. This is second of journey. This is third second, fourth second, like that. Okay. In first second of its journey, the body is covering a distance of, let us say, some 2 meter. Okay. It travel a distance of 2 meter in first second. Then in the next second, also 2 meter. Next second, also 2 meter. Fourth second, also 2 meter. Fifth second, also 2 meter. If the body is moving in this way, how covering equal distances in equal intervals of time, then you say the body is in uniform motion. So, in uniform motion, the body covers equal distances in equal intervals of time. The body covers equal distances in equal intervals of time. What is the interval of time we are taking here? 1 second each. This is 1 second interval. This is 1 second interval. 1 second, 1 second, 1 second. All are 1 second equal intervals of time. And what are the distances covered in these equal intervals? 2 meter in first second, 2 meter in second second, 2 meter in third second, 2 meter in fourth second, 2 meter in fifth second. So equal distances in equal intervals of time. Then you say the body is in uniform motion. The body is in uniform motion. Simple, no complications here. Okay. And for this to happen, is it necessary that the speed should remain constant?
No, sir.
No, sir.
Speed does not need not remain the same here. Okay, then tell me, what is the speed of the body in first second?
2
Sir, 2
meters per
meter per
second,
second.
sir.
2 meter per second. What is its speed in second second?
2 meters per second, sir. Same.
Third second?
Same, sir.
In all the intervals of time, its speed is remaining same. Suppose if in first second it is 2 meter per second, in second second instead of 2, if it becomes 3 meter per second, then what will happen?
It
The
becomes
body will
non-uniform
cover,
motion, sir.
the body will cover 3 meters in that particular second. Then equal distances will not be there. So point is, for this condition to be maintained, for this condition to be satisfied, the speed of the body should remain constant.
Sir,
The body
only the speed
has
should remain constant, or anything can be constant
no
except
speed,
speed.
speed. Only speed.
Only speed, sir.
Ah. So only when speed remains constant or when the body is moving with a constant speed, this will happen. Or in other words, in simple words, you say that if a body is in uniform motion, then it is moving with constant speed. Imagine there is a long straight road, no obstacles, and you are going in a car and you are driving the car at 50 kilometer per hour. Your speedometer is showing 50 kilometer per hour. If you maintain this speed as it is without changing it, it does not become 51, it does not become 49. If you maintain it as it is, then your car is in uniform motion.
Yes, sir.
That means if your speed is 50 kilometer per hour, that means you are covering a distance of 50 kilometer in each hour. First hour 50 kilometer, second hour 50 kilometer, third hour 50 kilometer, and so on. So you are covering equal distances in equal intervals of time. Then you are in uniform motion. So if speed of a body remains constant, its motion is uniform, or vice versa. If the body is in uniform motion, its speed will remain constant.
Sir, if the speed is constant, then only it is an uniform motion, sir.
Yes, that's what I am telling you. If speed remains constant, the body is uniform motion. If body is uniform motion, the speed remains constant. If speed is not constant, it is not uniform motion. And if it is not uniform motion, speed will not remain constant. However you twist and turn it, overall point is if it is uniform motion, speed will same. Speed will be same, it will remain constant. Okay. Then, if I want to study the motion of such a body, which is in uniform motion or which is moving with constant speed, what formula do I have or what formulas do I have? We have only one formula, which is speed equal to distance by time.
Sir,
Or
is this the only formula we use to find uniform motion?
wherever you find uniform motion, you have got only this single formula. There is no second formula to study uniform motion. So speed is distance by time. Okay. Next, this is uniform motion. Non-uniform motion. Non-uniform motion. The body is moving like this. It starts at time t equal to 0 second, moves for 1 second, 2 second, 3 second, 4 second, and 5 second. And the distances covered by the body are like this. First second, 2 meter, second second, 4 meter, third second, 5 meter, fourth second, 10 meter, fifth second, 1 meter. Distances are not equal. Distances are not equal. Okay. Or this can also happen. Body starts at t equal to 0, 1, t equal to 0. Okay. And let us say it covers equal distances. This is 2 meter. 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 But the times taken to cover these distances are 1, 3, 4, 8, 11 second. What is happening here? Take the first situation. Take the first situation. In first second, distance covered is 2 meter. In second, distance covered is 4 meter. Third second, 5 meter. Fourth second, 10 meter. Fifth second, 1 meter. So in equal intervals of time intervals are equal, 1 second each. In equal intervals of time, the body is covering unequal distances. Unequal distances. First second 2 meters, second 4, third second 5, 10, 1, like that. So equal, unequal distances in equal intervals of time. Or if I take equal distances, 2 meter, 2 meter, 2 meter, 2 meter, these distances are covered in unequal intervals of time. First 2 meter distance is covered in 1 second. Second 2 meter distance is covered in 2 seconds. 1 to 3, 2 seconds. It is traveling for 2 seconds here. Third 2 meter distance is covered again in 1 second. Fourth 2 meter distance, 4 seconds. Fifth 2 meter distance, 3 seconds. So these time intervals are not equal. This can also happen. If the body is moving like this, then you say that it is in non-uniform motion. So the body covers unequal distances in equal intervals of time, or the body covers equal distances in unequal intervals of time. If it is moving like this, you say that it is in non-uniform motion. Non-uniform, not regular, not organized or proper. It is moving abruptly. Non-uniform motion. Then, if the body is in non-uniform motion, what about its speed? Will its speed remain same throughout the journey?
No, sir.
If speed remains same, it will be in uniform motion. If it is non-uniform motion and if it is moving like this, then definitely its speed will not be same. Its speed will not be same. If speed is same, it cannot go like this. If its speed is same, it will be in uniform motion. So here, the speed of the body is not constant. Then only it will move like this.
Sir,
Oh,
so can the body cover unequal distances in unequal intervals of time?
yes, it can also happen.
Okay, sir.
So speed is not constant here. Speed is not constant. If speed is not constant means speed is changing with the time. Remember this point. In non-uniform motion, the speed of the body will be continuously changing with time. Then only it will be non-uniform motion. If you compare it with the previous example of you are driving a car at 50 kilometer per hour, this is only a idealistic assumption, right? It is not possible for you to drive a car at a constant speed 50 kilometer per hour practically for even 1 hour or 2 hours or 3 hours. You cannot do that even for half an hour, right? because there will be traffic, there will be traffic signals, there will be toll gates, there will be speed breakers, this and that. All kinds of disturbances will be there. Hurdles will be there. So
On
if
highway
you
we can do it, sir.
even on highway also, you cannot maintain speed for hours together. You can maintain that speed for a few minutes. Right? Some vehicle might come in front of you. Someone will be blowing horn behind you to overtake you. There might be speed breakers. Different things might happen. So practically, if a car is moving through a let us say through traffic, will it be in uniform motion or non-uniform motion? If you are driving through traffic, will your motion be uniform or non-uniform?
Non-uniform
It will
motion,
be
sir.
definitely non-uniform. Sometimes you go speed, sometimes you go slow, sometimes you stop. You travel, you move with different speeds depending on the situations of the traffic. So your motion will be non-uniform. You will be covering either unequal distances in equal intervals of time or equal distances in unequal intervals of time. Then your motion will be non-uniform motion. Okay, so I will take that example here. Example, motion of a vehicle through traffic. Motion of a vehicle through traffic. And for uniform motion, you can take example of a train, because this is possible for trains. Trains can maintain constant speed between two stations. Okay, so we can say motion of a train between two stations. Right. Is this thing clear? Difference between uniform and non-uniform motions. If it is okay, now the point is, you can use speed equal to distance by time formula to study motion of a body in uniform motion. But can we use the same formulas to study motion of non-uniform motion of a body?
No, sir.
We cannot use. Why?
Because the speed
Sir, can
changes
you
for
repeat
everything.
once again?
Speed is continuously changing. Which speed will you take?
Sir, that's why we should take average speed.
Calculating average speed every time is not convenient. And even the speeds are not same. The time intervals might not be same. So it is not always convenient to calculate average speed here. Okay. In that situation, to study the motion of a body which is in non-uniform motion, we have here a body which is in non-uniform motion. It has another new quantity, another new parameter. We get another new parameter to describe its motion, which is acceleration. Acceleration. Try to understand this term very, very, very clearly. Acceleration. What is this? But before we go to acceleration, one more point here. The things that we discussed here regarding uniform, non-uniform motion, we took speed here, distance, speed. The same things apply for displacement and velocity also. If a body is in uniform motion, its velocity will remain constant. If a body is not in non-uniform motion, its velocity will change. Okay, so speed or velocity. You include velocity also here. Speed is distance by time. Velocity is displacement by time. V is equal to S by T. Okay. And here also in non-uniform motion. Speed is not constant, or in other words, velocity is also not constant.
Sir, the acceleration is that only, no, sir, that we do in cars.
Yes. So if I speak in terms of, if I describe this uniform, non-uniform motion in terms of velocity and displacement, instead of distance and speed, if I describe them in terms of displacement and velocity, a body is in uniform motion if it covers equal displacements in equal intervals of time. And a body is in non-uniform motion if it covers unequal displacements in equal intervals of time or equal displacements in unequal intervals of time. Then, to study uniform motion, the formula that you have is speed equal to distance by time or velocity equal to displacement by time in uniform motion. In non-uniform motion, speed will be changing. As a result, velocity will also be changing. So if velocity continuously changes, you cannot apply velocity equal to displacement by time. Then what to do? To understand what to do, you should first of all know what is this acceleration. Acceleration, everyone might have heard this term, you might have used this, you might have seen this. We have something called accelerator in vehicles.
Yes, sir.
Accelerator in vehicles. If you raise this accelerator, what happens?
The
Acceleration takes place.
speed increases.
Speed increases. If you raise accelerator, speed of the vehicle increases. If you just decrease it, speed
Sir,
decreases.
speed decrease.
So
We
it
have to,
is a arrangement or it is a mechanism which can change the speed of the vehicle, which can change the speed of the vehicle or velocity of the vehicle. Okay. So we say that a body has acceleration if its velocity changes with time. A body, or I will write it this way, if velocity of a body changes with time, then the body is said to have acceleration. Only when the body velocity changes with time. If velocity does not change with time, the body has no acceleration. Velocity does not change with time. That means velocity is constant. If anything does not change, its value does not change. It's constant. So if velocity is constant, no acceleration. It's like that case where your car is going at constant velocity 50 km per hour. On the other hand, if velocity changes with time, it might increase or it might decrease, whatever. But if it changes with time, then the body has something called acceleration. Okay. How do we measure or how do we define this acceleration? See, acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. Rate means not in terms of money, with respect to time. Rate means with respect to time. So mathematically, we can write acceleration as change in velocity by time. Time during which that velocity is changing. Okay. To understand this, let us say a body is moving with initial velocity u at time t1, and at some time t2 its velocity becomes v. U is initial velocity, v is final velocity. initial time at time t1 velocity is u, at time t2 velocity is v. Then from this we can write acceleration. From the definition of acceleration, it is change in velocity. Change in velocity means change in any value is final value minus initial value. So final velocity minus initial velocity. Change in any quantity is its final value minus initial value. Suppose your height last year was 5 feet. After 1 year, it is 5 feet 2 inches. What is the change in your height? What do? You subtract initial height from final
2
height.
inches.
5.2 inches minus 5 feet 2 inches minus 5 feet 2 inches is the change in your height. So here also change in velocity is final velocity minus initial velocity. Final minus initial by time. Okay. Now using the symbols that we have here, that we standardly use, acceleration is represented by small a equal to final velocity is represented by v, small v, not capital. Initial velocity is represented by u and time by t. What is a here? Or what is u here? First of all, initial velocity. U represents initial velocity. V represents final velocity. You can remember them like U comes first, V comes later. So first is initial, last is final. UV. Then T is time, and A is acceleration. A is acceleration. Okay. Now this is the concept, definition, and formula of acceleration. What is the concept behind acceleration? If a body is moving with changing velocity, then it has acceleration. How do you define it? It is the rate of change of velocity. How much velocity changes in unit time. That is defined as the acceleration. Formula, change in velocity by time, or symbolically, A is equal to V minus U by T. So, sorry. Okay, I'll make one more change here. Can we write time duration? We can write this time duration as T2 minus T1. T2 minus T1. The duration of time in which this velocity is changing from U to V. T2 minus T1. Okay. Right. Or in another way, you can also write this as delta V by delta T. Delta V by delta T. This symbol, triangle, it is read as delta. It is a Greek letter, delta, and it is used to represent change in any value. So this delta is used to represent change in a value or change in a quantity.
Sir, here delta T means the
Change in time.
increase.
Change in time.
Okay.
Delta V is change in velocity. Delta T is change in time. Okay. So we have got the concept, definition, and formula for acceleration. Now, what is its unit? What is the unit in which you measure acceleration? What is the unit in which we measure distance? Distance is measured
Meters.
meter. Displacement,
Sir, meter only.
meter. What do we measure time?
Sir, second, sir.
Second. What is the unit of measuring speed?
Meter per second.
Meter per second. What is the unit for measuring velocity?
Meter per second.
Meter per second. Okay, like this, what is the unit of measuring acceleration?
The meter per second square.
If you take the formula for acceleration, acceleration is change in velocity by change in time. Acceleration is change in velocity by change in time. Change in velocity is also velocity. Change in time is also time. So ultimately it is velocity by time. Acceleration is velocity by time. So its unit must be unit of velocity, which is meter per second, by unit of time, which is second, which is meter by this second comes to denominator, second into second, second square. Meter per second square is the unit of acceleration. Meter per second square, or this can also be written as meter second power minus 2. This is a scientifically correct method to write the unit, but even if I write this also, no problem, it's understandable. Meter per second square. What is the unit of acceleration? Meter per second square. What is the unit of acceleration? Meter per second square. What is the unit of acceleration? Meter per second square. Why am I repeating this 3 times? Because I will confuse it with meter per second. When we come to solving questions, you will interchange the units. You will say speed is meter per second square, or you will say acceleration is meter per second. Don't let that happen. Have this clarity. Speed, velocity are measured in meter per second. Acceleration is measured in meter per second square. Meter per second square. And this acceleration is a vector quantity. Acceleration is a vector quantity. Okay. And these are all the technical things. Now, practically, physically, the point that you should understand from acceleration is, suppose if I tell you a car is moving with acceleration 2 meter per second square. A car is moving with acceleration 2 meter per second square. What should you understand from this? What should you understand from this? The thing that you should understand is this. If you understand this, acceleration is done. See, at time t equal to 0, let us say the car starts from rest. Rest means initial velocity is 0. The car starts from rest. Initial velocity 0. Okay, let us say travels for 1 second, 2 second, 3 second, 4 second, 5 second. If its acceleration is 2 meter per second square, it means 2 meter per second from the definition of acceleration. Change in velocity by time. Okay, 2 meter per second per 1 second. So if it starts with 0 initial velocity, u equal to 0. Basic point, if a body is having acceleration, its velocity will remain same or change. If a body is having acceleration, its velocity will remain same or will it change? It will change. It will change. Velocity will change here with time. Okay. How much is it changing in 1 second? It is changing by 2 meters per second.
2 meters.
Changing by 2 meter, not 2 meter. Meter is a unit of distance or displacement. We are talking about
2 meter
velocity.
2 meters per second.
2 meter per second. So here velocity of that body is changing by 2 meter per second every second. That's why we say that its acceleration is 2 meters per second square. That means after starting at t equal to 0 with initial velocity 0, after 1 second, its velocity will become 2 meters per
4
second.
meter per second square.
2 meters per second. 1 second, 2 meters per second. In the next second, it will increase by 2 meters per second. So it will become,
4 meter per second.
in another 1 second, it will again increase by 2, becomes 6. Again increase by 2, becomes 8. Again increase by 2, 10. Again increase by 2, 12, 14, 16. Like that, the velocity of the body is increasing by 2 meters per second in every second. That's what we call as acceleration of 2 meters per second square.
Sir, I have a doubt.
Ah,
Sir, 2 meter per second by second, that means that 2 meter second change for one each second, sir.
yes.
Okay.
See, all of you, if you have any doubts in this, get clarified them right now. Acceleration is going to become a very, very fundamental basic thing in our coming topics. If you don't have clarity on acceleration, you will not understand the coming things. And have a clear cut clarity between difference between velocity and acceleration. Many students confuse velocity with acceleration. They are not the same. Sarandeep.
Sir, so if any question comes related to this acceleration in exam, sir, so if you write 2 meter per second square or 2 meter second power minus 2, it's correct only, right?
Correct.
Okay, sir.
Again, I am repeating this. The body starts from rest with initial velocity 0 at t equal to 0 second time. In 1 second, its velocity is increasing from 0 to 2 meter per second. In the next second, it is again increasing by 2, 2 to 4. Next second, increasing by 2. Next second, increasing by 2. Next second, increasing by 2. Like this, if the body travels with a velocity which increases by 2 meter per second every second, then you say that its acceleration is 2 meter per second square. If I say that acceleration of a train is 5 meter per second square, how do you understand its motion? It starts at initial velocity 0. In 1 second, its velocity becomes 5 meter per second. Next second, it becomes 10 meter per second. Next second, it becomes, next second, like this. It increases by 5 every second. Then it has got 5 meter per second square acceleration. Clear? Acceleration. Okay. Then this acceleration, it can be of two types. Isn't this? Acceleration can be of two types. What are they? Velocity, we have defined acceleration as change in velocity. Change means the value can either increase or it can decrease also. If you are going in a car, if you press the accelerator, speed increases, velocity increases. If you press the brake, velocity decreases. So velocity can either increase with time or decrease with time. Both can happen. In either case, you have acceleration. In either case, you have acceleration because velocity is changing. But we define, we take if velocity of the body increases, if velocity increases with the time, then acceleration is positive. we treat that acceleration as positive. On the other hand, if velocity decreases with time, then acceleration is negative. Velocity increases, acceleration positive. Velocity decreases, acceleration is negative. Okay. And this negative acceleration is called retardation. Name we are giving. Negative acceleration is called retardation, or it is also called deceleration, not deacceleration. Deceleration. Retardation or deceleration. You can use anything, but more frequently retardation is used. Okay. So if you come across something like in the question, a body is getting accelerated, immediately you should understand that its velocity is changing with time. If it's just acceleration, it indicates positive acceleration, increasing with time. If you read the sentence like a body is getting retarded, you must understand that its velocity is decreasing with time. Acceleration positive, acceleration negative. Okay. If you push the accelerator, velocity increases and your acceleration is positive. If you apply brakes to a vehicle, your velocity decreases and your acceleration is negative, or you are getting retarded. You are getting retarded. If you apply brakes, when you push the accelerator, you are getting accelerated. Okay. Is acceleration clear? Is acceleration clear?
Yes, sir.
And a very, very important point is you should compare velocity with acceleration and try to understand how they are different from each other. This is a
Acceleration is
very
the change
important
in
thing.
velocity, no, sir.
Velocity is different from acceleration. Many students understand that acceleration is greater velocity, which is not correct. Acceleration is not velocity. If a body has more velocity, it's not like it has acceleration. It is not at all that. Rate at which velocity changes is acceleration. They are completely different from each other. Okay, right. So this is about acceleration and how you measure study motion of a body which is in non-uniform motion. That is our next topic, which we will discuss tomorrow.
Okay, sir.
Right. See you and good night.
Thank you, sir. Bye, sir. Good night, sir.